Good morning, my name is Kanishk and I'm going to give you a quick walkthrough for predicting life expectancy using machine learning. I've done the project using Python, so this is the 30% part which was for the auto AI experiment that I did not do because it was optional. Moving on, I've used two IBM Cloud services, the first being Node-RED integration by IBM Cloud and the second being the Watson machine learning. Apart from that, the continuous delivery and other related services that help deploy Node-RED. Moving on, this is my life expectancy using regression notebook that I'm going to show you in a minute. This is my deployed machine learning model. This was a test model. Don't need to worry about that. And this is my dataset uploaded to the cloud. Moving on. Hmm. So there are a few paths to this Jupyter notebook. The first part being uploading the data, second part being the exploratory data analysis, the third part being uh, one-hot encoding and imputation of data and scaling of numerical data. So later on, the parts being model selection and deployment. So here are my imports. Here I've imported my pandas data frame, my CSV file into a pandas data frame df underscore pd. Here starts the exploratory data analysis. Here is my data types to check which kind of data is categorical in nature, being the data being country and status. So moving on, here I was checking which data needs imputing or which has null values. So by this command we found that the following values have uh, have some data that is null in nature. So moving on, here I was checking that what is the distribution of data? Is it diverse enough? So we can see countries 193 and other kinds of data is quite sufficient in nature, is quite diverse, and I checked the dataset myself. There were a lot of instances for every country, so it was good data. It was a good data set. Moving on, this is the correlation matrix that I made to just see what the kind of correlation exists in the data and is the data set making sense logically. So we can see schooling, income, composition of resources, GDP, diphtheria, polio, BMI, percentage, expenditure, and alcohol, even year to some extent, are logical indicators of life expectancy. You expect these data sets, these features, to be highly related when we talk about the output of life expectancy. So moving on, uh, here is my categorical column pipeline, categorical transformer, where I used imputing categorical data with most frequent data in the column and one hot encoding for the status and country, as you can see. Then this is the numerical column transformer, where I've used impute numerical, which is basically imputing the mean value of the column, and scalar, which is a standard scalar to normalize the data. Now this is the prerequisite for all columns that we are going to use in our models, and you can see the categorical transformer for cat kind of data and numerical transfer for num type of data has been passed in this column transformer. So this was just some testing regarding how if it is working or not, and it did work. So moving on, let's just skip to the models, and I used four models. The first being the multiple linear regression model. I have passed my pipeline into all these models that I'm going to talk about later on, and let's just see the metric, the evaluation metric. There are two evaluation metrics that I chose and I find to be highly reliable. The first being the R2 score and the second being the mean squared error. The lower the mean squared error MSE, the better the model. The higher the R2 score, the better the model. So we can see that MLR gave you an R2 score of 0.96 and MSE of 3.68. Here was just some evaluation to see if on a metric where the uh, where the x-axis is year. Is my life expectancy making sense or not, or is similar to the actual data? So moving on to random forest, I have chosen the exact same metrics for comparison and analysis. So we can see the mean square error is 3.41, R2 score is 0.96. This is the best model by far. Moving on to regression, I can see that the mean square error is 5.26 and the R2 score is 0.94, which is lower than the previous ones. For elastic net regression, we can see that the mean square error is 3.72 and the R2 score is 0.96. So by final analysis, we can say that we can use the random forest model since it has the highest R2 score and the lowest MSE, while the last net regression and as well as the MLR gave the same R2 score, but they had a lower mean square error. So we deploy random forest model. So here is the code for random forest model deployment. Here is my API keys provided by the Watson machine learning client service, and here you can see my client repository list. This is the deployed model, and this is further code where you can see that this has been my scoring endpoint, which has been printed here. The other code shows error because it was run again uh, in between after another Jupyter notebook session. Otherwise the model has been uh, deployed as shown you here. So moving on to the node rate flow, you can see this is my node rate flow, which was provided by the IBM webinar, and they taught us how it is used. So let's go quickly on throughout this flow. The first is the form, where I put in the inputs, all the inputs of the dataset features apart from the label, of course. Here is my API key, here are my global set, this is the dataset, this is the form output set into a global variable. This is the HTTP request that asks for a token. This is the pre-prediction part where I take the uh, form data and I put this into the message payload, as you can see in this part. And furthermore, this is the HTTP request on my endpoint, scoring endpoint that I showed you just a second before. This is my form output, and this is the predictive life expectancy node. This is my final UI. I have put in some data set from before to save time. This is my predicted life expectancy, which is coherent with the CSV dataset that was provided. Thank you for your time. Have a good day.